All right, this is section 4.1, number 4. In this problem, we want to check whether these three functions are dependent or independent. So there are several different ways. One is using the definition of independent or dependent, right? So you can see that. So this is method number 1. You can see that I can actually write f of 3, which is this guy, as 4 times x. X is f1, right? And then minus 3 times x squared, and then you see that x squared is f2. So therefore, you can see that f3 can be written as a linear combination of f1 and f2. This already tells me that these three functions are dependent, because you can rewrite this as 4f1 minus 3f2 minus 3f3, minus 1f3 equals 0. And you can see that there's a non-zero coefficient, so that the linear combination is equal to 0. That means it's dependent. And then dependent, okay? Now, second way, if you want to use the Wronskian, and then you can just find the Wronskian of these three functions. So how do we do that? X, and then derivative of that function, and then second derivative of the function. Second one is x squared, and derivative is 2x, and second derivative will be just 2. The next one will be 4x minus 3x squared. The derivative is 4 minus 6x, and the second derivative is just negative 6. Now, to find the determinants of this guy, there are actually different ways to do that. One way is so you pick a row, pick arbitrary row, and then reduce that using that row or column. Actually, it doesn't have to be a row or column or row. So for instance, you can let me just pick the first column, for instance. So it can be written as x times the determinants of, so you're going to cross out the first row, first column, the determinants of 2x, 4 minus 6x, 2 and negative 6, okay? Now, because we are expanding using the first column, so the next one will be 1, but the sign will be alternate. So minus 1 times. Now you're going to cross the first column, second row. Then you have the determinants of x squared, 4x minus 3x squared, and then 2 and negative 6, okay? And again, so now time for us to look at the third entry, which is now sign should alternate. So plus 0 times, even though I know it's 0, but I just want to, for demonstration purpose, you're going to cross and the first column and first row. And this is going to be x squared, running out of space here, 4x minus 3x squared, and then 2x and 4 minus 6x. So this is, you can expand this 3 by 3 into like a sequence of 2 by 2, okay? So this is method number 1. Now, method number 2, especially for 3 by 3, actually it's pretty handy. So you can find the determinants using, so the first one is product of this diagonal, which will be 0 times 2x times 4x minus, actually I'm sorry, this should be, I think I made a mistake, so should be going this way first, okay? So the products of this diagonal, x times 2x times negative 6, plus now the diagonal, so this way, x squared times 4x, 4 minus 6x, and then go to this one, 0. You can duplicate these 3 by 3 and then write it here, then you know the next one here will be 0, because this column will be the next column, right? So it will be this one. So which is x squared times negative 6 times 0, okay? And then the next one will be this diagonal, 4x minus 3x squared times these two, the products of that two. So plus 4x minus 3x squared times 1 times 2. Okay, so once you finish this direction, then you are gonna minus. Now for the other three, you're gonna minus the products of this diagonal, which turn out to be 0, right? And then minus the diagonal of that guy. So minus 2 times 4 minus 6x times x. Okay, and then lastly, minus negative 6 times the product of these three. So minus negative 6 times x squared times 1, right? Now, time for us to do the simplification. The first one, we get negative 12x squared. Second will be 0. The next one will be minus 8x, actually plus 8x minus 6x squared. And this is 0. The next one will be minus 8x plus 12x squared. And the very last one will be plus 6x squared. And we do see that negative 12x squared is cancelled. Negative 8x, and then negative 6x squared, which is equal to 0. So because the Wronskian is equal to 0, we do know that it is dependent, right? Dependent. So that's pretty dependent. Okay, that's pretty much the how I would solve this problem. I would prefer to use this one because just by observing, it's pretty easy to find it.